All right, so welcome everyone to this talk about AndroidXR, adapting for the future and present. So so it's a very exciting topic because it's about something very, very new. I was there in Google I/O in San Francisco past May when they first announced all the the devices and all that. They did a demo. It was very exciting, and for us developers, that we need to basically adapt and to all these new ecosystems that keep getting into the users and all that. So let's see how we can leverage what we already know and the SDKs we already manage, and we already know how easy it is to integrate into existing applications or to create new applications and to take advantage of this new technology, AndroidXR. First of all, here's me. I'm an Android architect. I've been writing code for more than 15 years, and specifically Android apps for more than 11. I'm a GDG organizer as well. I live in Spain, but I'm originally from the Dominican Republic. You may not know that country, but maybe you've heard of Punta Cana, so it's the same place. So I'm a GDG organizer over there and also a Google developer expert in Android and also a follower of Jesus Christ. So let's see the agenda. Today, we're going to talk about what is AndroidXR, first of all. What are the available SDKs that we have to build applications with AndroidXR? What are the main or core components of this SDK? We'll see a demo app, and we'll talk about some advantages and challenges about that. It's just personal opinions of advantages and challenges I've found about AndroidXR and its SDKs. But I want to know, who of you know what this is, AndroidXR? Nope. Have you? Okay. So then this is also a no. None of you will have experimented with this. So AndroidXR is essentially an operating system. So they took Android, right, and they built a new operating system based on Android. The same that Android did with Linux, so they did it with Android. So they took Android, and this is a slightly modified, not slightly, a modified version of Android, which is AI focused, specifically for extended reality experiences, right? So it's not the same Android operating system that we use on our Pixels or the Samsung devices. This is a special one that is installed in these XR devices, all right? So this operating system was developed by Google in collaboration with Samsung and Qualcomm, right? So just last month, in October 2025, they announced the first ever AndroidXR device, right? Which is the Galaxy XR. So I took this video from the Galaxy XR page, and there you can see a demo of what they promise the experience will be if you buy one of these Galaxy XR. So essentially, you will have huge screens all over the place. You can get immersed into that experience, and then apps that are adapted for this kind of experiences can have this special look and feel that you can't have on a tablet or a phone, right? It's very specific to this kind of devices and this kind of operating systems. So the Galaxy XR was developed by Samsung and, as I said, was announced on October 2025. So as you see here, in this video, it's supposed that this is real life, right? And the person is just rounding the sofa, and then Google will let the people know information about it. So that's what they mainly propose, that you can, get your real life, AI powered, right? You're like, I'm seeing you, and I can maybe round you, and I can, it will make a LinkedIn research and whatever research on the internet to let me know more information about you. So essentially, we're getting closer and closer to Jarvis from Iron Man, essentially. We're getting there. So the Android SDK, AndroidXR SDK, is designed to let you build apps using the frameworks you know. So I assume that most of you or all of you are Android developers, right? Cool. So we'll have one of the SDKs provided by Google to build apps for XR. The first one is Jetpack XR SDK. Second one is Unity, and also OpenXR and WebXR, which are two open standard protocols or frameworks to basically build extended reality applications using these open source frameworks. One for devices, the other one for the web specifically. But we're going to focus on Jetpack XR SDK today. And so, as I mentioned, that we can use the tools we know, which are those. So first, Kotlin, we can use Kotlin, we can use Compose, and they even dared supporting XML and Java. We all know this wasn't a great idea, but we know that there's still a lot of legacy XML and Java, components out there that nobody wants to touch. Like in the company, there is that old component that is working, but it's hard to maintain. But nobody wants to touch it because if you touch it, it's like pandemonium over there. So yeah, if you're excited about writing code with XML and Java, you can keep doing it and build AndroidXR applications with it. So let's see the core components. We have mainly three. There's a fourth one that I want to mention, and there are more, but I focus on the main ones. And there's a fourth one that we'll see in the demo. But now let's talk about these three: modes, spatial panels, and orbiters. Let's start with the modes. In AndroidXR apps, it supports two modes. The first one is home space mode, and the second one is full space mode. What's the difference? In home space mode, you can think about it as a desktop experience, right? So if you're in your Mac or your Windows, you can have multiple applications open at the same time, multiple windows, right? So that's home space mode. You can have multiple applications like in a 360 3D experience running side by side. The user can use more than one app at the same time, right? And Android apps can run in home space mode without any modification. So you don't need to, if you have your app already created, you don't need to do anything specific to be able to run it in AndroidXR. There are a couple of limitations that I will talk about later, but mostly about permissions. It's just the same thing we have with the Android phones, right? That there are certain phones that don't have certain capabilities, and you can run your app in that phone because it doesn't have the hardware. So it's the same with XR. You just can run certain applications that require certain permissions. It's the same. So if your app doesn't require those permissions that are limited, you can just run it in home space mode without any special modification. But full space mode is like an immersive mode, right? You see, in Mac, when you maximize a window, right, it takes the whole space. You only can use one at the same time when it's maximized. So full space mode is something like that, right? You maximize it, and the user is focused only in your app and only can use your app at that certain moment. And for this specifically, the apps must do some additional work to enter full space mode, and in the demo app, I will show you how it is. Here is an example of an application entering and exiting the full and home space mode. So as you see in the home space mode, they have three apps. Then they enter the centered one, Jet News, and then it's like, okay, I'm focusing on this one. So that's mainly that concept. The next concept is spatial panels. So spatial panels are basically the fundamental building blocks of AndroidXR. So each one of those applications that you saw, each one of those was a spatial panel, right? That's essentially those rectangles that you can use to place your content inside. It's just that. Spatial panels serve as containers for UI elements, interactive components, and immersive content. And you can use them to build an XR differentiated app experience on an unlimited display. So you can see this animation. This person is essentially viewing three different spatial panels, right? With the three different apps, three different content, and all that. So when in home space mode, our app will be contained in a single panel, right? But when the user enters the full space mode, we as developers can use as many panels as we want, right? We can have 10, 20, whatever amount of panels because they are focusing on our application, and we can use as many panels as we want with different options, and I'll show you that also in the demo. The last concept I would like you to know right now is orbiters, right? So orbiters are floating UI elements, like the floating button that we used to have, that we have in materials, something similar. So the name is pretty like explicit. It's like floating thing that orbits a panel, right? Just like the moon orbits, So you can place it wherever you want, and you place there like contextual actions. So for instance, if in your screen, your content that you're showing, like the user can sort it or filter it, in the orbiter is where you will place those options, right? Now let's see the demo. You know that 9 out of 10 demos for Android are movie apps. So I didn't want to do something different. I didn't want to be different, so let's do a movie app XR demo. So yeah, it's pretty simple. There's no images. I just have like a list of categories, and when you click on a certain category, you will see a list of movies inside of that category, right? It's a very simple one. There's no network. Everything is in memory, just for you to see how it works, like the navigation, home space mode, full space mode. But as I said before, it's using Kotlin and Compose. So you can use Ktor, you can use Coin, you can use whatever you use in your normal apps, you can do it with the Jetpack XR SDK. There's no limitation for the Kotlin code you can write, for the Compose code you can write. It's just the same. And for that reason, I will be skipping some information on this demo, because I won't get into how I build certain components, because it's just Compose. It's normal Compose, right? So there's nothing different there. So this is the scaffold, right, of the app I just showed you. It's very simple. So we have I'm using the window size class to determine the size of the device, right? And for compact devices, aka for phones, we are showing only one screen at a time, right? So the user can be in the category screen or in the movie list screen, right? And I have a compose state stored above that if null, right, we show the category screen, there's no category selected, otherwise a movie screen. So this one, for bigger devices, right, I want to adapt. So I used this expanded layout composable that they have in the Android Code Labs, but there are canonical layouts that you can use, but I wanted to keep this simple. You can use list detail, whatever, but I wanted to keep this simple. Underlying expanded layout is just a row. You see that it accepts primary and secondary content. It's just a row that puts primary on the left and secondary on the right. That's it. And for bigger devices, right, if it's not compact, we'll show it side by side, right, because there's enough room for showing it like that. And I just did that, and this is how it looks in AndroidXR. I included a dependency, and that's it. Like you will see, if you look at the documentation, the get started page is very small. It's just include this dependency and maybe this some other thing in the manifest, and you're done. So yeah, I just ran it, and this is how it looks. So if you have an application that is already adapted for bigger devices, you're maybe very ready for AndroidXR. You will need, so I'll show you later how you can leverage spatial panels and all that. You will need to do maybe some rewriting, but on that front, but your app will be usable, even though you won't have like multiple panels maybe, or you won't support full space mode, but your app will be very ready. Look how I'm using here this app. So now we'll see how we just saw how our normal applications are mostly ready for XR, especially if we adapted it. But let's see how we can XR adapt our application, right? So make it more specific to XR. First of all, what we need to do to make it more XR friendly is managing how the user can enter the full space mode, all right? So first, we're gonna build, so this is just Compose, nothing XR related here. We're gonna build this toggle space mode button, which is a button that we will use for the user to click it, to go in, go out of the mode, and it's just this. So we'll have if the user is in home space mode, we wanna use this. Otherwise, we wanna use this. So there are a couple of things interesting in this code. First of all, we have this XR composition local called local spatial configuration, right? So that's given for free. So that gives you a lot of information that we'll see later. And here we'll also see the local spatial capabilities composition local, right? And from the local spatial capabilities, we are getting if we are actually in the full space mode by checking is spatial UI enabled, right? If a spatial UI is enabled, that means you are in the full space mode. From the spatial config, right, we get the functions that actually tell the system that this application should enter or exit the full space mode. So we're giving all this for free. So this is just all the code we need. Just get the composition local, call some, get a Boolean value to know in which case we are, and call a function. That's pretty much it. And in my top app bar, I will check if this device actually supports XR, and I will add this button only if this device supports XR. We can do this by also using the local space configuration, composition local, and checking the has XR spatial feature. So as you see, they developed this very developer friendly. So they already provided, these composition locals where you can get all the information you need about checking, okay, is this device XR ready or XR compatible? Is the user in full space mode, home space mode? So is everything over there? So you remember that when I talked about the core components, I said there is a fourth one that I will mention in the demo, and it's a very important one, and this one is a subspace. Essentially, a subspace is the XR full space mode scope. I will explain this, it's really easy. Whatever is inside the scaffold is what you see in home space mode. Whatever is inside subspace is what you see in full space mode, okay? It's just that. So as you see, you need to add at the same level, you have your app composable, right? Where you usually have your scaffold. So at the same level, you have your subspace, all right? Now, I said that, and what you place inside, as I mentioned, will only be visible in the full space mode. And why we need a subspace, and not only, why can't we just use a scaffold and that? It's because AndroidXR and its SDKs have some special XR composables that we need to use instead of the usual composed ones. So for instance, instead of row, we need to use spatial row, right? Instead of column, we need to use spatial column, right? So we have that kind of things, and some other that are even more specific that I will show you later. So, yeah, so essentially that. You have a spatial row, which is just the same, just a row that whatever content you place will be stacked horizontally, right? So that's pretty much the concept. And now, instead of the row, we can include our spatial panels. Remember that we talked about this, so this is just a composable. You will notice, maybe by now, you've noticed something interesting, which is the modifier is different, right? So we also have a different type of modifier for AndroidXR, which is subspace modifier, right? It's pretty much the same concept. As you see, required width, height, those are properties that we already have in the usual and the normal compose modifier, right? So this is built. So if you know compose, you know how to build AndroidXR apps right away. You just need to know the SDK. You just need to know the API, the functions, how are those named, where to use what, and you're ready. So, and then inside of your spatial panel, you just include your compose code. It's just normal compose code. You see there's nothing special there. I'm just including a scaffold, a box, and then my category screen. That's it. And this is where I told you that I wouldn't like to get into, because it would be just wasting time, me getting how I built category screen, because there's nothing special at all. And that's a good news, because you can just reuse your composables, right? When you create your subspace, it doesn't mean that you need to rewrite your whole app to support XR. You can just reuse your existing composables and just place it there, right? It's just like a mirror of your app, you're just using the XR spatial composables. And let's see how it looks. So here I'm running my app, and when I click the button, I get into the full space mode, right? But I just added one spatial panel, if you remember, the category screen. So let's add a second one. Since it's a row, I said, you can just put it together and we'll show it side by side. And now just a simple, just simple condition here. If the category is not null, we want to show another spatial panel with the movie screen inside, right? We'll pass our state, whatever. And there's two properties here that are interesting: drag policy and resize policy. So when you specify this, as I have it here, you're telling the system the user can drag this screen around, or this spatial panel, he can drag it around and he can resize it, right? So you can also control that, and you can control several other things, but this is like the two major ones regarding to the spatial panel. Now let's see how it looks. So now I run my application, right? I enter full space mode, and now if I click a property, a new spatial panel will appear. Is it easy? Hard? It's pretty straightforward, right? Pretty good, pretty good. Now let's do another experiment. Let's use this spatial XR composable. So let's change our spatial row with a spatial curved row, right? Something I forgot to put here is that it accepts some properties, and one of them is like a curve radius. So you can specify how curved you want it to be, right? It's not only default, so you can specify how curved it is. So now let's see how it goes. We run it, okay? Now we go into full space mode, select category, and now it is like more, spatial, more 3D type of thing, which is like, the way we want to do it. But sometimes you just want it to have a flat. Like if you want it to have a flat, you use space row. Otherwise, you can use a spatial curved row, and that's it. There is a way. Sometimes your app is built to be in full space mode. For example, I can imagine that Netflix, Amazon Video, and those type of applications want to run always in full space mode, right? So how you do that, or how you do it by default. So you just need to add this in the manifest, this property, XR activity start mode, set to start mode full space managed. And as soon as the user runs your application or opens your application, it will start right away in full space mode, right? Okay, so there is one component that we haven't demoed, which is the orbiter, if you remember it from the core component section. Now let's go back to our top app bar. This is the code that we had before. It's just a regular composed app bar. We have a title, and in the actions, you remember that we added the toggle space mode button that we created, and we are just adding it if this device is XR compatible. So all we need to do is wrap it in an orbiter. That's it. That's it. So what happens here? The orbiter only appears if your app is in the full space mode, right? If it's in the home space mode, it will appear as a regular button, which is embedded into the screen. Otherwise, it will orbit the screen. For the orbiter, you have several different properties: the position, alignment, offset type, shape, and there are more that you can use to actually customize your orbiter, right? Let's see how it looks. You will notice that now it is inside of the screen, right? The button. And as soon as you enter full space mode, it is like orbiting. So there you can add, whatever composable you want. Maybe a row with different actions, a contextual menu, whatever. So yeah, it's really straightforward, really nice. Cool. So let's talk about some advantages about AndroidXR that just my personal take. First, compliant Android apps are compatible out of the box. That's what I mentioned. So what I mean by compliant Android apps, basically what I said, the AndroidXR devices is a specific hardware, right? So in the documentation, you will find that there's a list of permissions that if your app require it, so that you have permissions that are not mandatory, right? That you requested on runtime and you can react to the decision of the user. Like if the user doesn't want to grant you that permission, you're fine, you do whatever you need to do. But there are certain permissions that we can mark it as a must, right? That the device that installed this application must have this permission. So there's a list of permissions that essentially, if your app requires one of these, you can't run your app in another XR device. So if your app is compliant with this, you can just run it out of the box. You just need maybe to add the XR dependency, and that's pretty much it. Another advantage is that there's familiar APIs. For us, the Android developers, we have the Jetpack XR SDK. For the Unity developers, we have the Unity SDK. And OpenXR for the ones that know that, so that's also great. As you saw, there's great interoperability. It easily integrates into existing app. They even created, that in Compose we have the Android view to have like view system elements inside of Compose. They created something similar. They created a special Android view, something like that. I think it's called something like that. So you can, continue interoperating with the view system inside of the XR world, right? And so as you see also, if you have an existing application, you can include a subspace and you don't need to affect your app production code. You just need to include the subspace and start adding your XR specific things right there. Also, it has great documentation. So if you go there, you will see there's a lot to read. It's not too long. I read it almost all like in the 1 or 2 days. And it's very detailed. So it's very detailed. Something that you need to keep in consideration is that XR is still in alpha. So you can maybe notice that there's some things missing here and there, but for something that is in alpha, the documentation is really complete. So it's great to have something like that. Some challenges that I noticed. First of all, it is not clear in the documentation how the navigation will be addressed. So let's give a brief history of how we've been doing things in Android for the past 15 years. So when I started in 2013, we used to have one screen, one activity, right? That's the way we had it. Like one screen, one activity, and then each activity has its XML. We navigated from one to another. Then we were said, okay, this is not right. Then they took fragments out with honeycomb. They said, okay, here's a fragment. With this, you can create reusable UI elements, UI components, and you can have a single activity. And in that single activity, you can have as many fragments as you want, right? So that's how we've been doing things since then, right? With Compose, the same, a single activity. Then now, instead of fragments, we have several composables that we navigate between each other. But now with XR, we are like going back in time because we, again, have different spatial panels, individual spatial panels, right? So you can't use, for example, they took out navigation 3 yesterday. I don't know if you saw it. It's stable by now. Assuming, I didn't check it out specifically related to AndroidXR. I'm assuming that they thought about XR in that navigation library. But for navigation 2, you don't have a straightforward way to leverage the spatial panels Because for you know that with navigation too, you have a single composable, which is your nav host, and inside your nav host is where all the navigation happen. You know, so this as you saw with the concept of XR and the spatial panels, it doesn't like quite match. You know, because we need it separate. So that's something I noticed. I said, okay, how is this going to work? This is something that, in my opinion, is missing. I didn't find anything in the documentation that will point me in the right direction. And how I did these examples, I took this is example from the code labs. So I just did it my way, but the way they have it for the navigation in the code labs is just that. It's just like you have a composed state, you set it, and you have a bunch of ifs. But what about an application where you have 20 composables, 20 screens? Like we are at Under Armour, we have our application is not small. Like just tabs, we have like 5. And inside of each one, we have like maybe 10 more screens that the user can go. What happens in that kind of application where we have several screens? So yeah, that's a concern, I have, but it's in alpha. I know they will get through it and they will bring a solution. Also, the AndroidXR emulator gestures can be improved. We don't want to buy a 2,000 or 1,500 euro devices to develop for this, right? So we need the emulator to work. And it's easy to integrate XR to an existing code base, but because of what I said in the beginning, if not done properly, it can lead to a very messy mix of things. It can be a very spaghetti code, hard to maintain with the time. So I hope by the time they make the SDK stable, everything is in place with the navigation, with everything, the architecture, and all that. You can learn more with the code labs. Here I left some QRs. There are 2 code labs, Fundamentals Part 1, Fundamentals Part 2. Really small. There are like 7 or 8 steps in that code in those code labs, and they go straight to the point because, to be honest, there's a lot to talk. It's not like a compose code lab where they need to teach you what is a modifier, what is a composable, what is a state, how you host a state, blah blah blah. No, with the XR they assume that you know what compose is, how it works, and they just teach you the differences, which are very small. And yeah, this was my presentation. Now it's time. We have some time for Q&A. Cool. So I don't know if any of you have any question. Thank you.